Today we are looking at the 2019 AdMath paper. Let's start question 1. So here we go. The function f is such that f of x is 2x cubed plus 7x squared plus 3x. Determine all linear factors of f of x. So f of x is equal to 2x cubed plus 7x squared plus 3x. And right away we recognize that x is a common factor in all the terms. So x factor out x, we end up with 2x squared plus 7x plus 3. Now notice in the bracket here we have a quadratic expression. So to factorize a quadratic, let's use the AC method. So AC is 2 times 3, that's 6. So we need two numbers that multiply to give 6 and add to give 7. And so 6 and 1 obviously will work. So 6 and 1 gives 7 in the middle term here. And of course 6 and 1 have the same product as A and C. 2 times 3, 6. Alright, so x, so we're going to rewrite this as 2x squared plus 6x plus 1x. So we rewrite 7x as 6x plus 1x. We have our plus 3 there. And we're going to factor by groups. We're factoring by groups. So let's just separate these. So let's use a square bracket to separate. So in the first group of terms here, we factor out 2x. So we end up with x plus 3. The second group of terms, the common factor there is 1. So we are left with x plus 3. And so we have a common factor there in the brackets, x plus 3. So x in the bracket there we factor out x plus 3. So we are left with 2x plus 1. And then we can put out, so x, this is x. This is x, right? X. And in the bracket here, x plus 3 is a common factor, 2x plus 1. So we end up with x plus 3, 2x plus 1. So these are the three factors, and notice each of them is linear. Compute the roots of the function. So we're going to equate. So if we let f of x be 0, we just rewrite the function using these factors. So we're going to write, so x plus 3, 2x plus 1 is equal to 0. So remember this was f of x, right? So we equate each factor to 0 and solve. So we equate x to 0. We equate x plus 3 equals 0. We solve this, we get x equal minus 3. And we put 2x plus 1 equals 0. So we subtract 1 from both sides and divide both sides by 2. X equal negative half would be one of the roots. As we move on, two functions g and h are defined as follows. So we want to find g of h, gh of x, a composite function. So gh of x is equal to g. And of course h, we can replace h with what it is. H is 2x minus 3. So in g, I'm going to replace the x. I'm going to replace the x in g with whatever we have in the bracket there. So x squared becomes 2x minus 3 all square. And minus x becomes minus what we have in the bracket there, 2x minus 3. And of course, if we wish, we can expand the bracket. If I expand the bracket, we'll end up with 4x squared minus 12x plus 9. Expand this bracket. This in minus, so it's minus 2x minus 3. That's positive 3. Group all the square like terms. So we have 4x squared. We have minus 12x minus 2x. That's minus 14x. 9 plus 3, that's 12. Now the question says, given that the composite function hg is equal to 2x squared minus 2x minus 3. Show that the values of x for which hg of x is equal to 0 can be expressed as 1 plus or minus root 7 over 2. So we're going to equate it. So hg of x, so we are told hg of x is equal to 0. And what's hg of x? X squared, 2x squared, rather, minus 2x minus 3. So we equate that to 0. And we try and solve using the quadratic formula. So the quadratic formula says x equal minus b plus or minus square root b squared minus 4ac all upon 2a. Remember, a represents the coefficient of the x squared, which is 2. B represents the coefficient of the x, which is minus 2. And c, the constant, negative 3. So we're going to plug these into the formula. So minus and then b, the value of b is negative 2, plus or minus square root of b squared, so that's negative 2 squared, minus 4 times a, which is 2, times c, which is minus 3, all over 2 times a, so all over 2 times 2 times 2, a is 2, right? So we end up with x equal to, so minus 2, that's positive 2, plus or minus, in the square root now we have minus 2 squared, that's 4, and then we have minus 4 times 2, that's minus 8, and minus 8 times minus 3, that's positive 24, all upon 2 times 2, which is 4. So we end up with square root of 28. So then hence x equal to 2 plus or minus square root of 28 all over 4. Now root 28, we can rewrite root 28 as root 4 times root 7. Remember root 28 is root, we rewrite 28 as 4 times 7. Alright, so this is root 4 times root 7. Alright, and root 4 is 2, so 2 root 7. Alright, so root 28 can be rewritten as 2 root 7. So this becomes x equal to plus or minus 2 root 7 over 4. So of course we can divide numerator and denominator by 2. So if we divide the numerator by 2, we have 1 plus or minus divided by 2. We have 1 root 7, which is just root 7. And divide the denominator also by 2. We end up with 2. So we arrive at what we were asked to show. That the root of the hg is 1 plus or minus root 7 all over 2. Next, x equal to 2. So we get this 3x here, we can raise 2 to that power. So log 2 to the power of 3x plus log 8 to the power of x is equal to 2. Now remember that log a plus log b equal log ab, right? So we can combine both terms by multiplying. So 1 log, and we multiply the terms here. So 2 to the power of 3x times 8 to the power of x equal to 2. And then now, so the assumption is it's base 10, that's the assumption. So which means that what's in the bracket? 2 to the power of 3x times 8 to the power of x is equal to 10. The base here raised to the power here 2. So we end up with what now? So 2, so we can rewrite same base here. So 2 to the power of 3x, rewrite 8. Now 8 is 2 to the power of 3, right? So 2 to the power of 3, and then times x here. 10 squares is 100. So this becomes 2 to the power of 3x. So we add same base 2, so we can add the powers, 3x plus 3x. That's 6x equal to 100. And now we can log both sides. So if we log both sides, we end up with 6x log 2 equal log 100, which is base log 100 base 10 is 2. 6x log 2 equal 2. And we're solving for x. So we can divide both sides by 6 log 2. So divide both sides by 6 log 2. So 6 log 2 cancel into itself, so 6 log 2. So left with x equal 2 over 6 log 2. I guess we can reduce it to 1, 2 into itself, 1, 2 into 6, 3, so 1 over 3 log 2. Question 2. Express the quadratic there in the completed square form. So we factor out the a, we factor out minus 2, so f of x. Let's factor out the minus 2. We end up with x squared. Divide this by minus 2, that would be about positive 7 over 2. Divided by minus 2, this would be positive 3, right? Positive 3. Now we're going to complete the square for the quadratic in the bracket. So we form our square there. Take the term there, x. Find half of, this is 7x. Find half of the b value. Half of the b value, which would be 7 over 4. Minus the square of 7 over 4. That's 49 over 16 plus 3. And then now we can redistribute the minus 2. So this becomes minus 2 x plus 7 over 4 all square. And then minus 2 times minus 49 over 16. That will give us positive 49 over 8. And minus 2 times positive 3, that's negative 6. So we need to 49 over 8 minus 6, so that's x plus 7 over 4 all square. And 49, right? So this would be 8 times 6 is 48, so it will be 1 over 8. 49 over 8 take away 6 would give us 1 over 8. Next, the maximum value. So the maximum value is usually the k value, right? So the maximum value. So maximum value of f of x is 1 over 8. The value of x for which the maximum occurs, the value of x would be whatever value of x makes the bracket 0. So that would be negative 7/4. Use your answer in A1 to determine all values of x when f of x is equal to 0. So if f of x is equal to 0, we equate this form equal to 0, which is the same as f of x rewritten. So we have minus 2x plus 7/4 square plus 1 over 8. So we equate that to 0. And we're going to try and solve this. So what we can do now, we can minus 1/8 from both sides. So we end up with minus 2x plus 7 over 4 square equal minus 1/8. And now we can, of course, divide both sides by minus 2, or you could say multiply both sides by minus a half. So the right hand side will give us positive 116. On the left hand side, that would be 1. So we're just left with x plus 7 over 4 all square on the left hand side. We can take the square root of both sides. So we'll end up with x plus 7 over 4 equal to plus or minus root 1 over 16, which is quarter. Root 1 over 16. So plus or minus a quarter. So x would be now equal to plus or minus a quarter minus 7 over 4. So x would be equal to, take positive a quarter first, minus 7 over 4. That will give me minus 6 over 4, or negative 1.5. Or we could say x equal minus a quarter now, minus 7 over 4. That gives us minus 8 over 4, which is equal to minus 2. So the solutions minus 2 and minus 1.5. Next, we're asked to sketch a function and show your solution set for a, show your solution set when f of x is less than 0. Alright, so let's do a sketch. So of course this graph would have a maximum because a, remember the coefficient of x squared, a was a negative number. So it's going to have a maximum. So the graph cuts the x-axis. So we have a negative 1.5 and that negative 2. So I cut it at, so I put negative 1 here. Negative 2 here. So you cut it at negative 1.5 and that negative 2, that's where you cut the x-axis. The turning point, let's look at the function again. The turning point, we found it, the turning point was the maximum value, negative 7 over 4 for the x, and 1/8 for the y. And it will cut the y-axis square now. It cut what was the c value? The c value was, let's look at the original function. The c value was minus 6. So this graph will cut the y-axis at minus 6. So somewhere about there. And the turning point was minus 7 over 4. Which is here, somewhere there. So minus 7 over 4. And positive 1/8 was the maximum. So minus 7 over 4. Positive 1/8. Alright, so the graph would look something like this. This is the maximum. Cut the x-axis at negative 1.5. Graph. It's an ugly graph. Could look better, but anyway. So you cut the x-axis at negative 2 and that negative 1.5. So negative 1.5. It cuts the y-axis at negative 6. So I'm sure you can draw a neater graph than that. Next, the GP can be represented as y over x plus y squared over x cubed plus y cubed over x to the 5, and so on. Prove that the sum to infinity is equal to that. Now, the sum to infinity is a over 1 minus r. So a is the first term, which is y over x over, that's the first term, 1 minus r. So we need the common ratio. Now, how do we get the common ratio? We can divide the second term by the first term. So to get the common ratio, we can say y squared upon x cubed divided by the preceding term, which is y over x. So this becomes y square over x cube, and this is just y square over x cube times x over y. So notice x into itself 1, x into x cube is x square, y into itself 1, and y into y square goes y. So the common ratio is y over x square. So and notice when you multiply y over x by y over x square, you get the next term, and so on. So this is y minus y over x squared. That's the common ratio. All right, this is what the common ratio is. So let's see if we can do this proof. So this becomes y over x divide by 1 minus y over x squared. Now we can write each, let's try 1 over 1. Let's rewrite this as let's rewrite the one as x squared over x squared. So this becomes y over x divided by x squared minus y over x squared, which is the same as y over x times x squared over x squared minus y. So x into itself 1, x into x squared x. So what we have is xy. So what we have is continuing is xy. So y times x xy over x squared minus y. And of course, this is x minus y to the power of 1. So if we rewrite this using indices, is xy into x squared minus y to the power of minus 1 using the law of indices there. And this is what we're asked to show? Yes, xy x squared minus y to the power of minus 1. Let's move on to question 3. A circle with center 1, -1 passes through the point 4, 3. Calculate the radius of the circle. Let's do a little sketch. So we have a circle. The center there is, the center of the circle is 1, -1. Alright. And there's a point pass through the point. Let's call this point 4, 3. So the radius will be the length. We'll call this r. So the radius, formula for length of a line is square root x2 minus x1 square plus y2 minus y1 square. So r will be square root. No, we can call this x1, y1, x2, y2. So x2 minus x1 would be 1 minus 4. 1 minus 4 all square plus y2 minus y1 would be minus 1 minus 3 all square. So r will be the square root. Now 1 minus 4 is -3. Square that, you get positive 9. And then minus 3 minus 1 minus 3, that's minus 4. Square we get 16. So r is the square root of 9 and 16, which is square root of 25. So the radius is 5 units. Okay, next we're asked to write the equation of the circle in the expanded form there. So equation for a circle is given as x minus h all square plus y minus k all square equal r square, where h and k represent the center. H is the x coordinate. Now the x coordinate is 1. So x minus 1 all square. And k is the y coordinate, which is -1. So it's minus 1. So it's y plus 1 all square equal r square equal r square. So remember r is 5, so equal to 5 square. So let's expand this. So expand the first bracket, we get x square minus 2x plus 1. Expand the second bracket, we get y square plus 2y plus 1, and 5 square is 25. So look at the form we're asked to put it in. So I'll put the x square, then the y square, then the x term, that's minus 2x, then the y term, that's 2y, and then the constant here is positive 1, and positive 1, that's 2, and then we subtract this 25 from both sides, so 2 minus 25, 0, 0 over here, since we subtract 25 from that side. So it's x square plus y square minus 2x plus 2y, 2 minus 25, that's minus 23, equal to 0. So if you compare it to this form there, you have 2fx, so, and here's negative 2x, so the f value will be minus 1, and the g value, 2gy, the g value will be just 1. Next, determine the equation of the tangent to the circle at the point 4, 3. So let us do the sketch again. So the center, remember the center of the circle was 1 minus 1. Alright, we have a point here, 4, 3. The tangent touches the circle once. That's a tangent, it's a straight line that touches the circle once, so that's a tangent. So to get the gradient, to get the gradient for the tangent, we'll need to find the gradient for the radius. Alright, remember the radius intersect circle theorem. The radius intersect the tangent at 90 degrees, they are perpendicular. So if we know the gradient for the radius, we'll be able to deduce the gradient for the tangent. So the gradient of the radius is y2 minus y1 over x2 minus x1. So again, we can call this x2 y2, and we can call this x1 y1. So I would be 3 minus 1 over 4 minus 1. So I will be 4/3. The gradient of I will be 4/3. So therefore, the gradient of the tangent, and this is what we call m, of course, would be equal to the negative reciprocal, which is negative 3, 4. Recall that if two lines are perpendicular, then the product of the two gradient must give us negative 1. So m, the gradient for the tangent, will be minus 3, 4. So hence, we need now to find a constant. Alright, so we can use y equal mx plus c. And we substitute the point the line passes through, the tangent passes through 4, 3. So we substitute 4, 3. 4 for the x, 3 for the y. So 3 for the y. M is negative 3/4. So 4 for the x plus c. So 3 equal negative, well, 4 into 4, that's 1, right? So negative 3 plus c. If we add 3 to both sides, c is 6. So therefore, equation of tangent is y equal mx plus c. Now m is negative 3/4 plus the constant there of 6. And one thing we could do is multiply each term by 4. So another form for the equation of the tangent would be 4y multiply 4y, multiply this by 4, that's negative 3x, and multiply 6 by 4, that's positive 24. So either forms will work for equation of the tangent. So now we are asked to find that product of P and Q. So P at Q, so the vector P is A2 That the vector q is 1i, so 1 minus 4j. So that product is 8 times 1 plus 2 times minus 4. So it's 8 plus minus 8, that gives us 0. So that product there is 0, which means that the angle, therefore the angle between P and Q is 90 degrees. So if that product is 0, I mean the two vectors are perpendicular to each other. Since P dot Q equals 0. Next. The position vector A is 4i minus 7j. Find the unit vector in the direction A. So the unit vector, so first we need to find the modulus of A. So the modulus of A is the square root of 4 square plus 7 square, which is equal to square root of 16 plus 49. That's the square root of 65. So the unit vector of A is 1 over the modulus of A times A. So the modulus of A is root 65, so it's 1 over root 65 times A, which is 4i minus 7j. I can just distribute the 1 over root 65, so I get 4i over root 65 minus 7j over root 65.